In the beginning of this unit, we started off by classifying reactions into one of two main categories, either double replacement or redox. Now, why are these two things two different categories in the first place, and what does redox really mean? That's what we're going to be digging into in this little video. So first of all, redox is a shortened collection of two different words, reduction and oxidation. That's where the read comes from the reduction, and the ox comes from the ox part of oxidation. Now, redox reactions are in their whole own category because they do something that double replacements do not do. Inside of a redox reaction, elements will actually change what charge that they have from reactant to product side. Again, this does not happen in a double replacement reaction, and this is why these are two different major categories of chemical reactions. Reduction means that an atom will end up gaining electrons, whereas oxidation means that that element will actually lose electrons during the course of the actual experiment. And there's a convenient little saying that can help you keep these two things straight, and that is Leo the lion says grr. Now, what that really represents, the Leo, the L-E-O in the Leo the lion part, means that you lose electrons in oxidations, and the grr would represent that you gain electrons during the reduction process. Now, there's also a little bit of an easier way to remember this because electrons with their negative charge can kind of be a little confusing to figure out if you're losing or gaining them. So it might actually just be a little easier to think about the overall charge of these elements at the time. Reduction. When an element gains electrons, its overall net charge will become more negative. You'll see a downward trend in the overall charge of that element. And the opposite is true then of oxidation. The overall charge of an element will tend to be in an upward trend. It will become more positive over time. Now let's take a look at what this actually looks like in a chemical reaction. Here is one where we have lithium reacting with calcium chloride. This is a single replacement reaction. It is one of the redox reactions, and therefore electrons must be being exchanged. So how do we actually prove that electrons are being exchanged in this chemical reaction? Well, one of the very first things that we're going to need to do is to identify the charges of everything on the inside of this reaction. Now, in chemistry, at least at this level, charges are often referred to as oxidation states or oxidation numbers. So again, just from right now, the oxidation numbers and charges are essentially going to be the same thing. So when we're identifying these charges, there's a couple things that you should know. First of all, plain elements. Now, these are not bonded. This is only when they're listed by themselves. Plain elements will always have a zero charge. They're completely neutral. Now, we do have two plain elements in here, lithium on the reactant side and calcium on the product side. So I'm going to put a little zero in the upper right-hand corner to represent their zero charge. Now, elements inside of a compound, generally they're going to be involved in an ionic bond and therefore ions themselves. We can look up those charges using those periodic tables and the periodic trends of what those charges would be. So for example, calcium tends to be +2, chlorine tends to be -1, and then of course on that product side we have lithium +1 and chlorine -1. Okay, great. Now we've listed out all of the charges, aka oxidation states, for everything on the inside of our reaction. Now let's figure out what has changed. So look at the reactant side, look at the product side, and determine, well, what elements did change charges? The first thing I notice is that lithium starts off with a zero charge and ends up with a +1. Well, that to me looks like an upward change in the charge. It became more positive over time. So we can actually say that the lithium has been oxidized. Let's see if there's anything else that's changed, because if there's oxidation, there must be reduction. I see that the calcium started off being +2, but then actually the charge trends downward back down to a 0. And it can only do that by gaining electrons. So we can say that the calcium has been reduced. Read Ox. Let's take a look at another example. So here is lithium combining with elemental chlorine to form lithium chloride. This is a synthesis reaction. Again, another classic example of redox, but we still need to prove it. So let's start by identifying the charges. Now on the reactant side, I have lithium and chlorine as elements. Those charges should be zeros. But on the product side, lithium chloride together is an ionic compound. I'm going to look up those charges on the periodic table. Lithium should be +1, chlorine should be -1. Next, let's figure out what has changed from reactant to product side. In this case, I see that the lithium has changed from a 0 up to a +1. It's become more positive over time and therefore is oxidized. I also see that the chlorine has gone from 0 down to -1. So with that gaining of that negative charge, that downward trend in charge, we call that reduction.